Welcome at this World Metrology Day movie about renewables, digital metrology and the energy transition. We are all used that at our homes we have electrical power with a fixed voltage and a stable frequency all of the time. This is not a trivial thing. The grid operators have to work very hard in order to provide this stable electricity supply, regardless of how many devices we plug in or out of the grid. And part of that effort is by doing measurements and installing measurement equipment. VSL, as the National Metrology Institute of the Netherlands, works together with grid operators and helps them perform these measurements in a reliable way by calibrating equipment and doing research into new measurement procedures and measurement techniques. One of the topics that you have obviously heard about is the energy transition. A lot of new renewable energy sources, such as photovoltaics and wind power, get connected to the grid. It's therefore natural to wonder whether or not this has an impact on the stability of the grid and what can be done to change any potential effects. In order to explore this question, I'm here with Gert-Jan Kok, who is a data scientist at VSL, and we will talk about how the grid changes and how data science can help mitigate these changes and make sure that also in the future we have a stable electricity supply without any hiccups or faults. So, Gert-Jan, can you say a little bit on what these challenges are?
There are two main differences between renewables and traditional power generation plants. First of all, you have the weather, which is constantly changing. For example, you can imagine that the sun is covered by a cloud and then all of a sudden the power generated by photovoltaic cells drops enormously. Well, similarly for wind speed changes. Another thing is that you have in classical power plants, you have massive rotating turbines, which have a lot of inertia, so resistance to change. So if something changes in the grid or in the natural gas supply or so to a plant, they still continue to rotate at more or less the same speed. And this creates a lot of stability in this classical power plants.
So the stability is being reduced by the integration of renewables. What kind of measurements are being done to monitor the stability of the grid?
Well, we have phase measurement units, so that's PMUs, and they are installed at different positions in the grid, and they measure especially frequency of the grid. So with this data, we can do a lot of things, yes.
So at VSL, these PMUs can be calibrated, but we're also developing methods and algorithms to use the data gathered by these PMUs.
We are doing research indeed to how to best use all this data coming from PMUs. And for example, you can detect events or like frequency dropping at certain points in time. And also like oscillations in the grids.
And are new data science techniques being used for that research?
Yes, that's a good point, Marijn, because traditionally we have these physics-based models, so mathematical models that really mimic the physics. But now this is not really possible anymore with all these renewables. So more techniques from data science are being used, like neural networks. And they are just fitted and trained with data. And then from that we can also make measurements of inertia and predict events.
Can you give a concrete example how data-driven techniques can help grid operators in their jobs?
Yes, we have been working at dynamic line rating algorithms. So based on the data from PMUs, you can estimate the temperature of a power line and then also set a dynamic limit on the maximum current that can flow through a line. So using this algorithm, you can actually use your grid better or put more capacity, more power through a line. And that helps also enormously in connecting new wind turbines and solar panels to the grid.
So as metrology institutes, we're always focused on the reliability of measurements.
Yes, and we validate them and also the algorithms.
Okay, yeah, that's a good point. So if people want to know more about this, they can contact us.
Yes, sure, yes.
Okay, thank you very much.
You're welcome.